Students, so now today's video, let us discuss about Mirage as well as a simple microscope, formation of image in simple microscope. So Mirage is optical phenomena that creates illusion of water in which inverted images of distant objects like trees are formed. Okay, so now here, now this is ground. Okay, right? Now here a tall object such as tree is present. On hot summer days, the air nearby the ground will be hot, right? There will be much heat nearby the ground. So these layers nearby the ground are hotter, right? So air density is very less in the layers nearer to the ground. As we go up, the layers at upper layers, okay, upper layers are cool. So density here will be more, right? These are lower layers. In summer seasons, this will be very hot, density of air will be less. So these lower layers acts as rarer medium, right? As we go up, you will observe, no, in hot summer seasons many people go for the hill stations. Why? Because as we go up in hill stations, there will be cool air. Okay, as we go upwards, the upper layers will be cool. So density of air will be more. So density is more. So these upper layers act as a denser medium. Okay, upper layer acts as a denser medium. Now light from sun comes and falls on this tall object such as tall trees, okay, such as a tree. Okay, now see here, this tree reflects this light. Okay, now we can say that light is traveling from denser towards the rarer medium. How the light rays are traveling? From denser to the rarer medium. Light is traveling from denser to the rarer medium. First point. From upper layer towards the lower layer. We can say no. So denser to the rarer medium. Now at one particular layer, lower layer, at one particular lower layer, this rays, okay, this rays incident with angle greater than critical angle. Okay, now at one particular layer, this rays refract with angle greater than critical angle. Now what happens when angle of incidence is greater than critical angle? The rays undergoes total internal reflection. Okay. Now here this ray at one particular layer, this ray has refracted. It has refracted. Okay. This ray has refracted with angle greater than critical angle. So it undergoes total internal reflection. Okay. And these reflected rays are going in upward direction. No? These reflected rays are going in upward direction. So now the observer, here is our observer. Observer will see the inverted image of this tree. Okay, in this total internal reflection, after total internal reflection has occurred, observer will see the inverted image of this tree. Okay, again I will draw the diagram clearly. Okay, now see the taller object. Okay, these are denser layers. Now these are rarer medium. Sunlight from denser medium, it is traveling and fall on tree. This tree reflects the layer, so it is coming towards the lower layers. At one particular layer, let us assume this layer, normal drawn, this is normal drawn. At one particular layer, okay, at one particular layer, this ray refracts with an angle greater than critical angle. Okay, so now when it happens, total internal reflection takes place, and these will reflect in upward direction. Here the observer is present, and this light reaches his eye, and he finds the inverted image of this tree. This illusion created to the observer of distant objects like trees in water, we call it as a mirage. Okay, so now it is formed due to total internal reflection of light. On hot summers, density of air is less near the ground, so due to heat, so it acts as rarer medium. As we go up, upper layers are cool and density of air will be more, so acts as denser medium. A light ray coming from distant object like a tall tree gets refracted from denser to the rarer medium. At particular layer, light is incident with angle greater than critical angle and suffers total internal reflection. It reflects upwards and observers see the inverted image of a distant object like tall trees. So this is about mirage. Now next, write with a neat labeled diagram, explain the formation of image in a simple microscope. So simple microscope consists of only one convex lens of a small focal length. This we also call as magnifying lens. So you will see magnifying lens in your college laboratories. So how it will be magnifying lens? Here as a point I just kept a magnifying lens only. A convex lens of a small focal length will be there. It is placed in a circular frame and a handle will be attached to it. That we call it as magnifying lens. For what we will use this magnifying lens? So these old people, or if any small letters are there, To enlarge that letters and read, we will use magnifying lens. Okay. So now let us see how the image is formed in such a simple microscope. Okay. So what I said now, this is principal axis. This the line drawn is principal axis. So it consists of a convex lens. Okay, this is convex lens. Now first let this be the principal focus. What is principal focus? A point on principal axis at which either rays appears to converge or diverge. Either the rays converge or appears to diverge. That point we call it as principal focus. Now object is placed. This is the object. It is placed between principal focus and this optic center of a convex lens. This is optic center, right? I kept a dot. Object where it is placed? Between the principal focus and optic center. Now illuminate the object with light. Now the rays from the object coming parallel to the principal axis. So this ray which I drawed is coming parallel to the principal axis. Refract and passes through the another principal focus f dash on principal axis. So learn how to draw the diagram. Diagram is most important. So the rays coming parallel to the principal axis refracts from the lens and passes through principal focus f dash, the ray 1, first ray. Next consider another ray. Let us assume that this another ray is passing through the optical center. Okay, another ray is passing through the optic center of the lens, and as per the rules of light rays, okay, we say that the rays which pass through the optic center will go undeviated. It just travel in a straight line like this, undeviated. Ray 2. Okay, the one ray parallel to the principal axis passes through f dash, after refraction through lens passes through f dash principal focus. Other ray which is passing through the optic center of the lens without any deviation, undeviated, it moves in forward direction. Now these two rays 1 and 2. Now this is one ray. Okay, I am drawing the dotted line, see, and this is another ray. These two rays, see here, they meet. Where they are meeting? On back side of the lens. Okay, left to the lens, not towards the right, towards the left, on back side of the lens, and produces image. Now this is image. So these two rays meet on back side of the lens, means towards the left side, means on that side where object has placed. Such images we call virtual image. So what we got? We got a virtual. And how image? As object is there, image is also there. Erect. And see the size of image, greater than object. So magnified. So we got a virtual, erect, magnified image. So in such a way, images are formed in simple microscope. Okay, so what is a simple microscope? I forgot to draw here. How it will be? A convex lens. placed in a circular frame and a handle is provided. This we call it as magnifying lens. The object where it is placed between principal focus F and optic center of convex lens. The light ray coming parallel to the principal axis refracts at the lens. It passes through second principal focus F dash. You just write as F dash. Another ray from the object passing through optic center, just correct this sentence, passes through optic center, goes undeviated. These two rays meet on backside of the object to form image. Thus, a virtual, erect, magnified image is formed. Okay. So, if you like this video, like it, share it, subscribe it. Yours, Reshma.